Hello and welcome. Our system is the Plant Growth Variable Monitoring System, and welcome to our final presentation. My name is Gavisha and I'm making this presentation with my friend Nelly. Let's move on to the problem. In traditional farming, a farmer has to check each and every single plant every day. The farmer has to check every single plant for their growth condition. And when the farmer check every single plant every single day, a large amount of time would be wasted. Through our system, we are going to measure the variables remotely, and we are going to make this system for a greenhouse environment. Let's move on to the proposed system. The system has an Arduino board. It also has an LCD display, a temperature and humidity sensor, a soil moisture sensor, a pH value sensor, a Wi-Fi module, and a GSM module. The Arduino board would gather the temperature, humidity, soil moisture, and pH values via the sensors, and it would send the gathered data to a computer using the Wi-Fi module, and an SMS will be sent to the greenhouse owner via the GSM module. The subject plant of our system is the kidney bean. The system can be coded differently to accommodate different plants. For an example, kidney beans need an optimal temperature of 18 Celsius to 27 Celsius. So if a certain kidney bean plant is lacking the optimal temperature, the farmers will know about that. Same goes for pH value and soil moisture level.
It should be mentioned that we could not complete 100% as we mentioned. The following shows what we have completed currently. So all the sensors will detect data and send it to the Arduino board, which runs with the 7.4 rechargeable battery. Then the LCD display will display the data while GSM module will notify the lacking amounts via SMS. It should be mentioned that our Wi-Fi module broken a week before the final presentation. Due to the current situation, we had no chance to go out and get a new one. So we had to do what is possible to do from home. Therefore, the web server and the database server part could not be implemented. Now, let us demonstrate what we have done up to now. Before going into the system, let's start with the plant. So I planted few seeds about a week ago just for this project. And now, as you can see, they are in a great position to test this project. Now, let's talk about the system setup. The system should always be in the right side, while the plant should be in the left side. That's because the input sensors of the system are in the left side of the system. Now, let's talk about the sensors that we place inside the plant. First, we have the soil moisture sensor to measure how much water in soil. Next, we have the DHT11 sensor to measure the temperature and humidity. And the last but not the least, we have the pH sensor to measure the pH value of soil. Let's see the system components. First, we have our main component, and that is the Arduino board. Everything in here is connected to that. It is powered by 7.4 volt rechargeable battery. Next, we have the input sensors in the left side. Following on, it is LCD display to display everything taken from the sensors. Then we have the breadboard, which contains common ground, and 5 volt power comes from Arduino board to power up the sensors. And the last one is the GSM module to send messages when required. Let's get closer and see how this system works. The detected values from the sensors will be displayed in the LCD display. Additionally, it will mention how good or bad is that value for that particular plant is. For an example, kidney bean requires a temperature between 18 Celsius and 27 Celsius to grow well. So, based on the detected value, the effect will be mentioned. If something lacks, GSM module will send a message. For example, if the amount of water is really low, the GSM module will notify the user. That concludes our final presentation. We feel really sorry and disappointed about the part we could not complete it due to the current situation. But we would like to thank everyone who is watching this video. Thank you very much again.